So first off, what's firmware? Well, firmware is the code which will run on the controller. So we take all these particular files, we combine them with others like libraries in the ESP32 core, and then generate machine code, which is binary, which will actually run on the controller. So that's what we mean by firmware. File system are all the data files, so there could be web files, JSON, JavaScript, all sorts of images, all those files that we want access to when the controller is actually running the firmware. So they will all be found in the data folder. So let's take an overview of what actually happens. We start off with all the source code, which is in the INO file, all the header files or the class files, as well as everything else that we need to do. And we run it through a thing called a compiler. And what the compiler does is it takes all those source files and generates .o or output files from all of those things. It also converts all the libraries, the source code sitting inside the library, to a .o file, an output file, and it does the same for the ESP32 core. So once you've got everything translated to .o files or output files, they are then combined by a thing like a linker. And what a linker does is it takes all the O files from source, takes all the O files from the library, and takes all the O files from the ESP32 core and generates a single file, normally a .bin file, which can be uploaded into the controller. And once it's uploaded, when the controller reboots, it'll actually start running all that firmware. So that's an overview of the process. What we'll look at now is the Arduino IDE and how to set the target board and the board settings, and looking at the tools menu. In the previous video we showed you how to select one of the boards that are in this project, and that was relatively easy to do. In the tools menu we have to make sure that the correct board is selected and all the other parameters are also selected correctly. What I'll do now is I'll go through the actual firmware itself, and we'll look at what you need to do to configure this before you can actually use the Arduino IDE to compile, link and upload the various outputs that are needed to run the controller. Right, so knowing the step size, you would have selected a particular motor as well as any possible gearing, and thus a driver board to give you the required step size or close to it. If you decided to implement this on a board, a readily available PC board, then obviously this one here would be your best bet. So let's just enable this like this, and we have to ensure that all the others are disabled. So for the CDLSU board, of course, these are your options. For the TMC board, those are your options. For the TZT board, those are your available options. And for the terminal adapter board, those are your options. So we're going to use PCB, and we'll put a DOV8825 with an EM stepper motor on it. Next thing is fixed step mode. So this is applicable to all boards which require a fixed stepping mode value. If I just quickly pop over here and have a look, and this is in the board definition file, and I see here that if I choose this particular board, then it supports a step mode of 1 to 32. So because I can change the step mode within the software that's running, it means that FSM has to be set to -1. So if it specifically says FSM, that means that that FSM has to be set to a particular value, which is not -1. So if it's not an FSM board, and this one clearly isn't, you must set FSM to -1. So let's just go back to config, and so I've set it to -1 here. Next step is motor revs per revolution, motor steps per revolution. And we are using a PG5 myesp32s3. So the steps per revolution is 2056. If we had chosen a PG5 for a NUMA stepper, then we'd have a look at the table, and at full steps it's 1028, at half steps it's 2056. So you need to know what step mode you're running and what motor you're using, and you should have figured all of that out in part 1 of the PDF, because it will tell you how to do that. So, and then it's just a matter of coming here into config.h and setting it correctly. Next thing, the controller can either act as an access point or a multiple access point or a station by itself. And I'm going to use this as a station. It's going to connect to my own Wi-Fi network. We can specify in the station configuration that it either be a dynamic IP, meaning the router provides a IP address back to the controller, or it can be static IP, which means that that IP address never changes, and when the controller starts, it tells the router this is the IP I want to use. When dynamic means it's changing all the time. Right, so the other folder we need to have a look at is data, where all our data files are, etc. Defines folder has specific defines for specific things. So for example, the app defines file is going to look like this, and this is where you can change your default device name and your MDNS name, and you can make those changes here. Can you actually change these when it's running? Yes. So these are the defaults. So that's that defines. READWIFICONFIG is a special file. It's a text file which contains the login credentials for logging into a particular network. So it specifies a certain password of the network within this file. There are two places where that information can be held. One of them is in READWIFICONFIG, and the other is in a defines file, which we'll look at shortly. MDNS is a way of accessing a controller using a name rather than an IP address. So that's quite handy. We're going to look at this in detail a bit later. If you want OTA, you've got two choices. You can have a standalone server, at which point you do that, or you can have the OTA server run underneath or as part of the management server. If you didn't want to use the management server at all, of course you'd choose a OTA server. But remember that the management server is enabled by default and you can't change that. Next thing is, do you want a display, an OLED display? And so 3 types are supported. There's a standard text display where various information appears on various screens, etc. There's a LilyGo display, which is about half the size, where you can display sort of minimal data. And there's a graphics display, which some people prefer. So this is a combination of text and icons. DUCKDNS is a way of accessing the controller across the network, across a public network. What we would say is remotely. So if you've got a remote observatory, 10, 20, 30 clicks down the road, what you do is you'd use DUCKDNS to access it. And we'll be talking about DUCKDNS specifically in another video. Another option is to include a custom config file, and it's called custom_config.h, and you can override a lot of things in that particular file because it's the last thing that will be looked at, and so anything that's happened before you can actually overwrite. And the full details of all of that is covered in the PDF, and I would expect that the majority of people wouldn't actually use this. Alright, so that's basically it for config.h. Alright, so the other folder we're going to look at is the defines folder, because it contains a lot of interesting information. The information in these files are the defaults. Once the firmware is up and running in the controller, you can actually change the majority of these without having to reprogram the controller. So you got basically 2 choices: change some things here, meaning you don't have to worry about it later, or ignore some of this stuff and then just try and reset things later on using the management server. There's a default device name for this, which you can change here if you want, but this is the default one. And there's also a default MDNS name that you can also change. This is the DUCKDNS defines file, which holds the domain and the token, which when you create an account on DUCKDNS, it will provide these values. And so then what you do is you can paste the values in here, so that when you start DUCKDNS, it'll already be configured. Next up is management defines. This defines the username and password used to log into the management server. You don't find this anywhere else. It's not something that you can change once the system is running. So the system itself only knows about it when it's actually compiled, and from that point on you can't find it. Obviously that's for security reasons. This is the information for OTA, which contains a name and contains a password. So that information is contained on that page. Next are the page colors. So these are the default colors of various things like title color, subtitle color, and so on. And this is probably a little bit redundant now, because previously we only had one definition which was assigned to all pages, and we didn't have such a thing as a colour scheme. But in the latest firmware revisions we've got colour schemes, and a lot of different ones are provided, and it makes life a lot easier. So I'd recommend you don't even have a look at that. Soft AP, this is for an access point. So for an access point you have to define its IP address, you have to define where the DNS server for the access point is, you have to give a gateway address. What is the address that other devices such as station controllers can connect to, and a subnet mask. Every Wi-Fi network has its own CERD and its own password, and they're configured here for this soft AP. There is a file for grouping together the various station settings. So this is the network that I'm going to connect to, my home Wi-Fi, and this is the password that I use to connect to that. This is the network to which the controller, because I'm going to be programming it as a station, the network that I'm going to connect to, my access point, is called my home Wi-Fi, and it has its own password. There is an additional set of credentials. If the first set fails, then it will go on to use the second set. So you can have, and they don't have to be the same. They could be the same, but they don't have to be. So this is like a pullback if the first set fails. And as a station, you've got a choice of dynamic IP or static IP, and these are set up for a static IP. So the address of the controller will be 192.168.0.142, and then you have to define the gateway address of my home Wi-Fi, which is 0.1, as well as the subnet mask and the DNS values of the domain name servers. And I configured all of that to run on my home Wi-Fi. The last defines file you have is only for the TMC chips. If you're not using a TMC 2209 or the TMC 2225, then you don't have to worry anything about this. But if you are, then these values will be important to you. So you'll need to set stall value to a specific value once you start tuning it. You need, if you're using a TMC 2209 and it's like 400 milliamps per coil, you'd change it to 400, obviously. Please don't change the 57600. Okay, otherwise the controller will not be able to talk to the driver chip. And then there are other values which you get from spreadsheets, etc. These shouldn't need to be changed because you should be using the big tree TMC chips, and if you are not using them, I can't provide you with any other values that make sense.